Hello everyone, thank you for joining me for our very last lecture in Econ 250. So congratulations for making it all the way, almost all the way to the end of the semester, right? I can really congratulate you at the end of this video. And honestly my heart breaks for you a little bit, imagining how sad it's going to be to go through all of winter break without getting any new economic theory. Okay, so what we're going to be doing today is we're going to be expanding on our analysis of game theory from last class to think about situations where instead of having just a small number of choices, right? Do I snitch or do I stay quiet? Do I work hard on my group project? Do I slack off on my group project? You have a whole range of choices, or what we'll think about as continuous choices, right? How hard do I work on the group project, right? From spending 0 hours to spending as many hours as I want. What price do I charge for output that I produce? How much output do I produce? All of these are going to be things that are really difficult to lay out in a game like we did in the past, because we'd eventually have, millions or hundreds of millions or infinite number of columns for all of the different options for each player. So what we're going to be doing is we're going to be taking the equilibrium concepts we got from our game theory lecture last time, particularly Nash equilibrium, and thinking about how to use those concepts algebraically rather than just in a game framework. Now, the main way we're going to use this lecture, we might play around a little bit at the end, but the main way we're going to use this in this lecture is try to understand a market structure we'll call oligopoly. Now, what I mean by oligopoly is a market structure where instead of having a single firm that is the only producer of an output, like in a monopoly, or hundreds or millions of firms, none of whom have any power over the price, like a competitive market, we've got something in between. Some sort of a market structure where we've got a couple of major players, none of whom can decide by themselves what the price and output is going to be in the economy, because their competitors make their own decisions. But each of whom has a significant role to play, right, has enough power that their choices about how much to produce or what price to charge influences market equilibrium. Now, the reason that studying oligopoly is going to require game theory is exactly because in an oligopoly, the decisions of one firm, let's say Intel, are going to depend on the decisions of their competitor, like AMD, right? When General Motors wants to decide how many cars to make this year or how much to charge for their cars, they're going to need to know what Ford is doing. When Dell is deciding what computers to build, what specifications to put on their computers or how many they need to build or how much to charge, their decision is going to depend on the decision of Toshiba and their other competitors. And so this is exactly the sort of situation that game theory is designed to understand, right? Situations where we have strategic interactions between different players, where my best move depends on the decisions that my competitors make. Great. Now, what we're going to be doing today is working through a couple different ways that these sorts of oligopoly market structures can result in equilibrium outcomes. So the conclusions we're going to draw about what the consequence of an oligopoly is going to be is going to depend on the specific decisions we make about how to model the oligopoly. And this isn't a mistake, right? And the couple of versions of this that we're going to lay out today are just a small number of a pretty wide range of different potential oligopoly outcomes. So this is another opportunity to really reflect on one of the important lessons from this class overall, which is that while each of our models is true, right? We can prove the consequences of each of our models. If we want to think about the real world, it's very important to ask the question, which of the assumptions that we could potentially make to model a situation are going to be best reflected in the real world situation that we're trying to understand. One last thing I want to say, if you find this lecture interesting, if you think these kinds of strategic interactions between firms is something you want to understand better, the branch of economics to really focus on is called industrial organization, which is all about understanding the decisions of firms in different circumstances. Cool. Let's start with Cournot oligopoly. Now, the basic idea with Cournot oligopoly is we've got multiple firms who are identical to each other, producing the exact same output as each other, right? Consumers don't care who they're buying from. And each firm decides how much output they're going to produce without getting to know how much output their competitors are going to produce. And as a result of that, the amount that they're able to charge for the output they produce is going to depend both on their own decision about how much to make, but also on the decisions of their competitors. They're going to have some ability, right, to produce an amount of output that will result in a high price, but they're not going to be able to do that to the same degree as a monopolist we might expect, because of the fact that they've got to worry that their competitors will produce more output. So the basic setup, right, we've got multiple firms producing the same output. Firms choose how much output to produce. And the price depends on all firms' choices of how much to produce. Great. So to think about this example more concretely, let's think about, for example, Ford and General Motors, each deciding how many trucks to produce for the next year. So we might imagine that, because building trucks is going to require you to set up a whole factory, right, which takes a lot of advanced planning to decide what capacity you want to build for. They're going to have to decide how many trucks to produce before they know the price that they can charge for the trucks that they make, and before they know how many trucks their competitors are going to produce, right? So Ford and GM are making trucks. Right, and we'll imagine for now, for the sake of argument, of course this isn't true in real life, nobody cares who they buy trucks from, a truck's a truck's a truck. So let's say that the demand for trucks, right, again, is a single commodity, it's going to be QDP equal to 50,000 minus 1/2 P. And Ford and GM have the exact same marginal cost. The marginal cost of Ford is going to be 20,000. And the marginal cost of GM is going to be 20,000. Okay. So then the question is, what are Ford and GM going to do? So if they were a monopoly, right, who had a marginal cost of $20,000 in this demand curve, they would produce until price equals marginal revenue. And if they were acting like a competitive industry, right, they would produce until price equals marginal, I'm sorry, what did I say? If they're acting like a monopoly, they're going to produce until marginal cost equals marginal revenue. And if they're acting like a competitive firm, they're going to produce until marginal cost equals price. So what are they going to do if they're neither of these two things, right? If they're somewhere in between? Well, to think about this, let's start by using the same tools we looked at last class, imagining that each firm had three choices. They either produce like a monopoly, they produce like a competitive firm, or they produce somewhere in between. So if they were a monopoly, right, we would say that their inverse demand, P of Q, would be, what would it be, 100,000 minus Q. So as a result, their, minus 2Q, what am I doing? So their marginal revenue, right, would be 100,000 minus 2Q minus 2 times, right, dP into Q is 2 times Q. So it was 100,000 minus 4Q. If I set marginal cost equal to marginal revenue, we'll get 20,000 equals 100,000 minus 4Q. Q is going to equal 80,000 over 4 is going to be 20,000, right? Or Q is 10,000 each. On the other hand, right, so this is kind of the monopoly extreme. On the other hand, we have the competitive extreme. Where they would set marginal cost equal to price. So they would say 100,000 minus 2Q equals 20,000. They would produce a Q equal to 40,000, right? 80,000 over 2. So each firm would make 20,000 trucks. And then we'll say the in-between just pick out of a hat. Let's say that Q is going to equal 30,000. Little q is going to equal 15,000, right? Each company makes 15,000 trucks, just because it's somewhere in between what they do in a competitive market and what they would do in a monopolistic market. So given these three kind of candidates, these three possibilities for how this competition will play out, let's think about using our game theory setup from last time. Which of these is going to be their optimal choice?